laws of motion as stated by Newton. We will start with the basics by first paying a tribute to Newton. Newton wrote this book in 1687. This book is still the cornerstone of mechanics. This book is about classical mechanics, which is the study of the motion of bodies. This is the book in which Newton laid down his 3 laws of motion that we will study today, and this is the cornerstone of mechanics even after the passage of more than 300 years. So let's get started with the first rule. The first rule states that every body remains in a state of rest or of uniform motion in a straight line unless an external force acts on it. This means that if a particle is at rest, it will remain at rest. If a particle is in uniform motion, that means it is moving with a uniform velocity, a constant velocity. It will continue to do so unless an external force acts on it. So that is the first basic law of motion, and this is also known as inertia. Now, before we move to the second law of motion, let's first go over the different kind of forces. For example, in the first particle, I have labeled the weight which is acting vertically down. In the second diagram, I'm labeling a force by which this particle is being pulled to the right. If this is a string, then this force will be called the tension in the string. Now, if this surface is a rough surface, that means there should be a resistive force over here. So now let me label this resistive force as F. F could be a frictional force. F could be some other kind of resistive force. Let's call it resistance. Similarly, over here, a particle is moving down. So this force is mg. Now, mg is the weight of an object. Now, let me go back to the first diagram and let me label R. What is R? R is known as normal reaction force. Now, the word normal over here means perpendicular. This is the symbol for perpendicular. Now, let's look at the last diagram. This is the weight of the object and it is attached by a string. So this is the tension in the string. This particular diagram forms the cornerstone of connected particle. There is a separate video on it. Now let's move to the second law of motion. This law states that the resultant of the forces acting on a body is equal to the mass of the body multiplied by its acceleration in the direction of that force. That means if I have a body and a force of 10 Newton is acting this way and a force of 4 Newton acting this way, this is identical to a force of 6 Newton pulling it to the right. So over here, this 6 Newton is the resultant force. This 10 Newton is pulling it to the right. This 4 Newton is opposing it. In other words, a resultant of 6 Newton is pulling it to the right. So let's use the symbol F for resultant of all the forces. Let's call it the resultant force. Let's use the symbol M for mass of that object. Let's use the symbol A for acceleration. Now we know that the unit of mass is kilogram. The unit of acceleration is meter per second square. In other words, the resultant force is a product of mass into acceleration. Therefore, the unit of resultant force should be kilogram multiplying with meter per second square, which looks really messy. So an alternative unit was proposed for force. We call it Newton in honor of Sir Isaac Newton. So resultant force is mass into acceleration. This will be used in conjunction with kinematics, whether we will be using the concept of graph or gravity or equations of motion. So now let's move ahead and let's try out few simple questions such as these. So question number 1, it says find the weight of an object in newtons of a particle of mass 12 kg. So just a simple diagram. This is a particle and the weight is acting downward. F is equals to ma. Instead of F, we have W. W is the weight of the object. Mass remains the same and acceleration due to gravity is mg. That is how we get this formula. So the value of g is 10 meter per second square. The value of mass is 12 kg. Therefore, the weight of the object is 12 multiplying with 10, which comes out to be 120 Newton. That is the first basic question. Let's look at the second question. It says find the acceleration when a particle of mass 1.5 kg is acted on by a resultant force of 6 Newton. F is equals to mass into acceleration. Resultant force is 6, mass is 1.5, and we are multiplying it with A. So let's make A the subject, which is 6 divided by 1.5, which is the same thing as 60 divided by 15, playing around with decimals. So therefore, the value of A comes out to be 4 meter per second square. So just two basic questions related to Newton's law of motion, in particular, the second law of motion. Now we are at the third law of motion. It states that for every action, there is an equal and opposite reaction. For example, let's look at this diagram. This is a table. A book is there on the table. The weight of the book is acting downward. The normal reaction is acting upward. In other words, the normal reaction equals to weight. So weight is actually the same thing as normal reaction, provided no other forces are acting on it. Similarly, we can see that there is a car on the road. The weight of the car is acting down. Normal reaction force is acting up. Therefore, R is equals to mg. So that is the application of Newton's third law of motion. Now, let's try out some basic questions such as these. Let's look at the first question and then the second question. But before that, let's read the question. In each of these diagrams, the body is accelerating as shown. Find the magnitudes of the unknown forces x and y. Now, first of all, both these examples relate to horizontal motion. That means motion is in the horizontal direction. In the first diagram, the particle is moving to the right. In the second diagram, the particle is moving to the left. That means let's first deal with the other forces such as y and such as 2g. And in the other diagram, we have y, we have 20 Newton, and we have 4g. So let's first deal with it. When we talk about y, that's the upward force, and 2g is the downward force. So the value of y is 2g because it's not in the direction of motion. The value of g is 10. So 2 multiplying with 10, that comes out to be 20 Newton. That is the value of y. Similarly, when we talk about y in this example, y is acting up, 20 Newton is acting down, and 4g is also acting down. Now, don't be misled that 20 Newton is above the particle, so maybe it's acting up. It's nothing like that. Look at the arrowhead. The arrowhead is pointing down. This arrowhead is pointing down. So these two forces are pointing down. This is pointing up. That means the value of g is 20 plus 4 times 10. So 20 plus 40, that adds up to 60 Newton. That is the value of y. Now let's focus on particle A. Now let's talk about the motion. The particle is moving to the right. That means the rightward force is greater than 4 Newton. In other words, the resultant force is x minus 4. That is equals to mass, which is 2 kg, into acceleration 2. So therefore, x minus 4 is equals to 4. Therefore, x is equals to 8 Newton. That is the application of the Newton's second law, F is equals to ma. Resultant force is x minus 4. Why is it x minus 4? Because it's moving to the right. That means x is greater than 4. So x minus 4 is the resultant force. That is mass into acceleration. Now let's look at diagram B. This time it's moving to the left. That means 80 is greater than x. So the resultant force 80 minus x is equals to mass of 4 into acceleration 2. 80 minus x equals to 8. Therefore, 80 minus 8 equals to x. Therefore, the value of x is 72 Newton. Now, basic questions such as these form the basis of more difficult questions to come, whether it's about a particle whose weight is acting downwards and there is a tension and it's moving up or it's moving down with an acceleration, things like that. These are all applications of Newton's law of motion. Naturally, we would come across resolution of forces. We would be talking about inclined plane. So all these questions would require at a certain point the application of Newton's laws of motion, and that is what the video is all about.